Welcome back. In this video we will discuss how to solve a radical equation. But first of all, let's introduce what a radical equation is. As you can see, a radical equation is any equation that contains the variable inside the radicand, like this, okay, in which the variable x is located inside the root. To proceed and solve one of these equations, the main objective is, the first one, the root must be alone in one side of the equation. And then we square both sides of the equation to eliminate that root and then see what happens. What are we talking about when we say eliminate a root like this, or when we have to talk about solving an equation? Example number 1. Let's analyze it. So let's solve the following equation. The square root of x plus 3, and this is equal to, let's say, 8. So if we have the square root of x plus 3 and that equals to 8, obviously what I need to do is eliminate this root so that this x can be in operational form. So what we do is we copy the original equation, x plus 3 equal to 8, and then we proceed to eliminate the root by applying the inverse operation. And in this case, the inverse operation indicates me that I have to use a power that is going to cancel this root. Since this is a square root, what I will do is square both sides of the equation. Once I square both sides of the equation, then the properties of radicals and the properties of power allow me to do this. And we have x plus 3 equals to the result of 8 squared, which is 64. And as you can see now that we eliminated the radical from the equation, what we have is a linear equation that can be solved by the regular inverse operations. So this will become x equals to 64 minus 3, and therefore x will be equal to 61. How do we confirm that the answer is correct? We do a very brief checking of the value in the original problem. And we proceed to replace 61 plus 3, and the answer of this has to be equal to 8. 61 plus 3 is equal to the square root of 64, and the square root of 64 is 8 equal to 8. And since we have a true statement, then we have the solution of the equation. Then x equals 61 is the right answer. The checking is optional in your problems if you know that what you did is correct, but it is always a very good help to see that we have a checking and that this checking leads me to the correct answer. Now let's analyze a different type of problem in which we are going to be using also the powers and the radicals in the radical equation. Let's see the next one. Example number 2. Let's solve the following equation. Square root of 3x minus 6 equals to 0. As you can see in this problem, the square root is not alone on the side of the equation. I need to move this negative 6 to the other side and then be able to apply the procedure of squaring the problem. So let's copy the problem with the inverse operation already in form. So 0 plus 6, then the square root of 3x equals positive 6. And now in here is where we come to the part of my root is alone, this number is alone in here, I can apply squaring the process. Remember, this is to cancel the root, and then 3x will be equal to 6 to the second power, which is equal to 36. And then this 3x equals to 36, we solve it by inverse operations. This 3 is multiplying, so when it goes to the other side, it goes dividing with the same sign that it has. So the final answer is equal to 12. And this is the solution to the problem. Remember always to check your procedure, okay? You bring the 12 in here, 12 times 3 becomes 36. The square root of 36 is 6. 6 minus 6 will become 0, and therefore the problem is correctly done. Now let's analyze a possible situation that we may have in here. Let's take a look at example number 3. Example number 3 tells me that I need to solve the following equation. X plus 1 plus 10 equal to 0. Now, when I have that situation, what I need to do again is isolate my root from the rest of the equation, and then let's see what happens, what can be done. So, by leaving the variable alone, what we're going to do is, first, square root of x plus 1 equals 0 minus 10. And then square root of x plus 1 equals negative 10. Here we have a situation. Some people will go automatically doing the operation of solving the problem by the inverse operation, and then let's analyze how that goes. Okay? If I apply the procedure, I do this. X squared, square, this cancels my root, and then what I have is x plus 1 equals negative 10 to the second power. That means negative 10 times negative 10, which is positive 100. And then, when I solve this equation, 100 minus 1, x will become 99. So, let's analyze what happens with this 99 that I have in here. I bring the 99 into the equation. 99 plus 1, to the original equation. 99 plus 1 is equal to 100. The square root of 100 is equal to 10. 10 plus 10 will never be equal to 0. Again, the checking. 99 plus 1 plus 10 will be equal to 0. 99 plus 1 is 100. 100 plus 10, well, the square root of 100 plus 10, this becomes 10 plus 10, which, as you know, 20, will never be equal to 0. So, if this is giving me a false statement, then 99 is not a solution. And since we have no other alternative, then this equation has no solution at all. Now, we can also analyze the problem from here as an alternative method. If I have the square root of x plus 1 equal to negative 10, I analyze. By rule and by definition, any square root cannot give me a negative answer. So if I have a square root that is equal to a negative number, automatically I say no solution. No solution. So I avoid doing all this process just by applying a rule of the real numbers that tells me that the answer, the square root of a number, cannot be a negative value. So, if you want to do it this way, perfect. This shows me that you're doing a procedure and that you are justifying mathematically an answer. If you go by this, also you are saying the same thing, and you are simplifying your work just by applying the root. Now let's go with a final example for this section. I hope that you're understanding right now what is happening with equations whose variable is inside a radical. Now let's deal with this one that requires a little bit more procedure. Example number 4. Let's see the square root of 2y squared minus 9 equal to y. Can we have another variable in the equation? Yes, but we still have one that is inside the radical, and that's what makes up the radical equation. So what we are going to do now in here is, okay, apply the process that we know up to now. So we copy the problem exactly as it is, and then we proceed to square both sides of the equation. I cancel my root in here due to the properties of radicals and powers, and what I have in here is 2y squared minus 9 equal to this expression square. So as you can see in here, what we are dealing with is a quadratic equation, an equation that has power 2 as a higher exponent. When we have a quadratic equation, what we usually do is solve it by factoring, quadratic formula, or by any other process, another process that is called completing the square. In this case, let's see if we can factor this by factoring. Solve it by factoring, sorry. So we bring down 2y squared minus y squared minus 9 equal to 0. And in here, 2 minus 1 will be equal to positive 1. Y squared minus 9 equal to 0. So, as you can see, we ended up with a difference of 2 squares. So, let's take this and solve it using our famous zero product property. Because what I'm going to do is identify that I'm going to have the square root of y squared, which is y, and the square root of 9, which is 3. So, what I have is y minus 3, y plus 3, and all this equal to 0. And therefore, I have y minus 3 equal to 0, or y plus 3 equal to 0, and finally, y equals to positive 3, or y equals to negative 3. Now, we have a situation. As you saw in the previous example, in number 3, we ended up having what is called an extraneous root. Extraneous roots are roots that lead me to a false answer. So now I need to do the checking of the two answers to see if the problem has a solution or not. So in this case, we need to do checking when y is equal to 3. So we bring y equals to 3 to the original equation. 2 times 3 to the second power minus 9, and this will be equal to 3. If you remember, we're replacing the 3 in every y that we see. So this becomes 3 to the second power is 9. 9 times 2 becomes 18. 18 minus 9, square root, has to be equal to 3. So 18 minus 9 is 9. Therefore, what we have is the square root of 9 is equal to 3, and then 3 equals to 3, and this answer is correct. Now, let's do the checking for the second one. Okay? And then we do the checking for y equals negative 3. So we proceed to replace y equals negative 3 in the original equation. So the square root of 2 times negative 3 to the second power minus 9, and all this equal to negative 3. So negative 3 times negative 3 becomes 9. 9 times 2, 18. 18 minus 9, and this should be equal to negative 3. Now, 18 minus 9 is equal to 9. So the square root of 9, negative 3, But in here, we have a problem. 3 and negative 3 are not the same. So then this is a false statement. And negative 3 is what we call an extraneous root. Okay? Now, let's remember, the extraneous root does not belong to the solution set. So, in this case, the only solution for this problem will be y equals 3. So, the solution set to this radical equation will be only 3. Negative 3 will not be included. So I hope that the problem is clear for you. We analyze options in which we have all of them being answers, and in this case, 2 examples in which we obtain what we call extraneous roots, roots that cannot be part of the solution, and therefore they don't belong to the solution set. See you on the next class.